Mossbridge, a neuroscientist and researcher, has proposed an intriguing perspective on the hard problem of consciousness by drawing a comparison to the behavior of bosons in quantum physics. The hard problem of consciousness, famously articulated by philosopher David Chalmers, refers to the difficulty of explaining why and how subjective experiences, qualia, arise from physical processes in the brain. Mossbridge's approach suggests that consciousness might share certain characteristics with bosons, particularly their non-local and indistinguishable nature. Here's an explanation of her ideas. 1. The hard problem of consciousness. The hard problem centers on the question: how does subjective experience emerge from physical processes in the brain? While neuroscience can explain correlations between brain activity and conscious experiences, it struggles to explain why these processes give rise to subjective awareness. 2. Bosons and their unique properties. Bosons are a class of particles in quantum mechanics, e.g., photons, gluons, that follow Bose-Einstein statistics. Key properties of bosons. Indistinguishability. Bosons of the same type are fundamentally indistinguishable from one another. For example, two photons in the same quantum state cannot be uniquely identified. Non-locality. Bosons can exist in superposition states and exhibit entanglement, meaning their properties are not confined to a specific location in space and time. 3. Mossbridge's analogy, consciousness and bosons. Mossbridge suggests that consciousness might share some of the non-local and indistinguishable characteristics of bosons. Here's how her analogy works. A. Indistinguishability of conscious experiences. Just as bosons are indistinguishable, conscious experiences might not be tied to specific, unique locations in space and time. This challenges the classical view that consciousness arises solely from localized brain activity. Instead, consciousness might be a more distributed or global phenomenon. B. Non-locality of consciousness. Bosons can exhibit non-local behavior, e.g., quantum entanglement, where particles instantaneously influence each other regardless of distance. Mossbridge proposes that consciousness might also exhibit non-local properties, meaning it is not strictly confined to the brain or body. This aligns with some interpretations of consciousness as a fundamental aspect of the universe. C. Consciousness as a fundamental property. Just as bosons are fundamental particles in physics, Mossbridge suggests that consciousness might be a fundamental property of reality, rather than an emergent property of complex systems like the brain. This idea resonates with panpsychism, the philosophical view that consciousness is a universal feature of all matter. 4. Implications of Mossbridge's theory. Beyond the brain, if consciousness shares properties with bosons, it might not be entirely dependent on the brain. This could explain phenomena like near-death experiences, altered states of consciousness, or collective consciousness. Unified framework. By linking consciousness to quantum phenomena, Mossbridge's theory offers a potential bridge between neuroscience and quantum physics, two fields that have traditionally been seen as separate. New research directions. Her ideas encourage exploration of non-local and quantum-like aspects of consciousness, potentially leading to new experimental approaches in neuroscience and psychology. 5. Challenges and criticisms. Lack of empirical evidence. While the analogy is compelling, there is currently no direct experimental evidence linking consciousness to bosonic behavior. Complexity of quantum systems. The brain is a warm, wet, and noisy environment, making it difficult to sustain quantum coherence, which is necessary for phenomena like entanglement. Philosophical debates. The hard problem of consciousness remains deeply philosophical, and Mossbridge's theory does not fully resolve the question of how subjective experience arises. 6. Conclusion. Mossbridge's comparison of consciousness to bosons offers a novel and thought-provoking perspective on the hard problem of consciousness. By drawing parallels between the non-local, indistinguishable nature of bosons and the elusive qualities of subjective experience, she opens up new avenues for exploring consciousness as a fundamental aspect of reality. While her ideas are speculative and require further empirical support, they contribute to the growing dialogue between neuroscience, quantum physics, and philosophy in the quest to understand consciousness.